fecal transplants could play a huge role in the medicine of the future. Effective treatment for a range of diseases, from irritable bowel syndrome to arthritis and even Alzheimer's disease, comes from the most unexpected source, human feces. James Kinross explains the role of the gut microbiome in our health. This is an excerpt from James Kinross's book, Dark Matter: The New Science of the Microbiome. As a nation, we Brits are obsessed with the workings of our intestines, mainly because they have never been more unhealthy. I spend much of my working day talking to patients about their bowel habits, and many of them don't want to talk about anything else. There is also a deeper and more fundamental fascination with the digestive system, evidenced by the mention of human waste left and right, which has helped people cope with both personal and global crises since time immemorial. Shit is a key and ubiquitous word that serves as a noun, verb, and adjective, underpinning the entire English language. This wonderful word is both profanity and a term used to denote something of high quality, and it is widely used in the everyday chatter of our lives. The feeling of disgust we experience when confronted with human feces, or even just thinking about them, is partly a reaction to how they look and smell. But this disgust is also a psychological reflex, deeply rooted in potty training and social stigma. This aversion serves as an important safety mechanism. Handwashing and sewage systems prevent the spread of diseases that have claimed the lives of millions of people. But what if I told you that feces are not toxic waste and that they contain the secret to human health? Would you eat them if your life depended on it? What if they were renamed fecal microbiota transplantation, FMT, or, more specifically, fecal milkshakes delivered through a tube that goes through your nose into your stomach? You could even take them in capsule form if you wanted. To convince you that this might not be such a terrible idea, let me tell you a story about one patient. Raymond drove bus number 7 between Oxford Circus and East Acton from the age of 20 until he retired early at around 40 after discovering that he had genetic heart issues. He quit his job at the doctor's insistence. Like you, me, and everyone else on the planet, Ray was a carrier of several trillion microbes that lived in and on his body. From our first breath to our last and even afterward, microbes are our ubiquitous companions. While they reside in various places within our bodies, they particularly favor our intestines. The gut microbiome is the term we've used to describe not only the wildly diverse collection of microbes that live there but also what happens when they interact with each other and with our bodies. In other words, it's an ecosystem made up of trillions of microbial life forms that go about their business inside us, just as we go about ours. Over the past 2 decades, scientists have begun using the new science of the microbiome to reshape our understanding of human health. Throughout his life, Raymond's gut microbiome changed alongside him. But over time, his genes and gut microbiome began to clash, leading to multiple chronic diseases. Ray and his wife Heather were tackling various health issues together until he fell ill with severe pneumonia. He was hospitalized at St. Mary's Hospital in Paddington, London, where he was treated with intravenous antibiotics. Without this, he would have simply died. He was discharged after a week. However, it was at this moment that a terrible catastrophe began in his gut as a reaction to the antibiotic therapy. Imagine the worst possible diarrhea, unbearable nausea, and intense cramping stomach pain that robs you of sleep. Now imagine that you were already weak before all of this. Your heart is functioning at 40% of its normal capacity, and your lungs are filled with fluid. You can't breathe. Additionally, the arthritis you have means you can't make it to the bathroom on time. You are cold, damp, and severely dehydrated, but you can't drink enough to quench your thirst. You feel like you need to wash, but you are too close to death to go take a shower. Ray has been readmitted to St. Mary's Hospital in critical condition, and soon he was diagnosed with a Clostridium difficile (C. diff) infection. This bacterium is now officially renamed Clostridioides. A hospital-acquired infection. This illness is a complication of 20th-century medicine and an unintended consequence of Alexander Fleming's discovery of penicillin, the first effective mass-produced antibiotic, in 1928. It is a global problem affecting 500,000 people worldwide. In the United States, 29,000 of them die from it each year. C. diff depletes the human body by producing toxins that damage the intestinal mucosa. A particular strain of C. diff in Raymond's intestines was involved in an aggressive campaign of molecular warfare. His personal collection of gut microbes disappeared. His intestines failed, and he was dying. And he was treated with antibiotics again. This seems illogical, but it is in line with best practices. However, C. diff has a trick up its sleeve, which is to produce antibiotic-resistant spores that lie in wait for their chance to germinate. Raymond was given an antibiotic called vancomycin. Many patients respond to vancomycin, but about a quarter experience a recurrence. And among those who do, 45% will have a recurrent relapse. These are the patients who usually benefit from FMT, or in other words, good poop. Dr. Ben Malhotra, a clinician scientist from Imperial College London, conducted an FMT trial in patients with C. diff infections. Ray was so ill that Dr. Malhotra offered him the treatment. Ray's wife understood that there are good and bad microbes and advised her husband to agree to it, but Ray was hesitant. The idea of taking someone else's feces was too distasteful for him, and he refused. However, 3 days later, his condition worsened so much that there was simply no other option. Ray accepted the risk. One should not underestimate the logistics of preparing FMT, fecal microbiota transplantation. Finding fecal donors is more complicated than you might think. Most of us are squeamish about pooping in pots at an adult age, and even when necessary, it takes considerable effort to accomplish this act. In some studies, friends and family participate as fecal donors, while in others, staff members, volunteers, or, combined, samples from multiple donors mixed together are used. The complexity and demand for fecal transplants have given rise to an entire industry, and now FMT can be purchased in frozen form from biobanks. Just like with organ donation, donors must be thoroughly screened to ensure they do not have infectious diseases or parasites. Potential stool donors undergo a rigorous screening questionnaire, a medical interview, and examination, followed by blood and stool tests. There are also practical aspects. Ideally, fresh samples should be obtained shortly after delivery, diluted with sterile saline, mixed, filtered, and then poured into a sterile bottle. Dr. Malish's work can sometimes be less than glamorous. After the fecal cocktail was mixed, shaken, not stirred, the transplant was introduced to Ray during a colonoscopy. This procedure uses a flexible instrument that is inserted into the large intestine through the anus, and the intestine is gently coated with a soothing balm of microbes that are administered through the colonoscope using a syringe. A little history. While FMT may be a new idea for many of us today, the medical practice of fecal transplantation is ancient and has been consumed like yellow soup since the 4th century AD to treat infectious diarrhea. In 1958, pioneering surgeon Dr. Ben Eiserman was administering fecal enemas to his patients in Denver, Colorado, suffering from severe and recurrent infections caused by C. diff. It was remarkably effective, but like all important medical discoveries, his findings were largely ignored in the initial description in the medical literature. More than half a century later, Dutch gastroenterologist Josbert Keller and his team from the Amsterdam Medical Center randomized patients with recurrent C. diff into 3 groups. The first group received vancomycin, bowel lavage with a powerful laxative, and a fecal transplant. The second group was treated with vancomycin and bowel lavage, while the third only received vancomycin. The group receiving FMT showed such significantly better results than the other 2 groups that the study had to be terminated early, as continuing the experiment was deemed unethical. The race to understand how FMT works has already begun. We know that it restores bile metabolism, a digestive fluid produced in the liver and stored in the gallbladder, which is metabolized by bacteria, and this, in turn, blocks the growth of C. diff and controls the infection. It is also likely that a process of bioremediation occurs, in which donor microorganisms consume and break down toxins present in the recipient's gut. However, there are trillions of organisms producing an endless number of bioactive molecules, and each disease has its own unique microbiome. Therefore, it can indeed be somewhat akin to turning a computer on and off. It's a complete reboot of the gut's immunological software. It also becomes clear that samples from some donors are significantly more effective than those from others. They are known as superdonors, and their feces seem to contain a magical ingredient that makes them particularly effective. However, we do not understand why this occurs or whose feces will be the most effective. Nonetheless, FMT is currently being studied with varying degrees of success in hundreds of trials worldwide. These include trials for inflammatory bowel disease, irritable bowel syndrome, obesity, acute malnutrition, diabetes, arthritis, hepatic encephalopathy, decreased brain function due to severe liver disease, liver transplantation, skin cancer, autoimmune diseases, Alzheimer's disease, developmental disorders of the nervous system, bipolar disorder, hair loss, depression, neurodegenerative diseases, and recurrent urinary tract infections, to name just a few. Some of these studies are extremely promising and offer treatment where there are few effective medical options available. For example, FMT appears to be a promising method for treating irritable bowel syndrome, and a recent study shows that its benefits may last for many years. 125 patients were randomly assigned to receive either 30 grams or 60 grams of feces from the same donor or a placebo transplant containing their own feces. Researchers not only found that FMT improved symptoms, but also observed a sustained positive effect 3 years after its application. Unlike C. diff, where dramatic and acute clinical changes are caused by a specific pathogen, the impact of FMT is less obvious in chronic painful conditions, where it has not yet been proven that bacteria are the cause, or where we are unsure how the disease develops. As a result, at the time of this writing, recurrent C. diff was the only clinical condition in the UK and the US for which regulatory agencies approved the use of FMT. The gist, pun intended, is that we do not yet have a good enough understanding of how FMT works or its long-term risks to start using it more broadly in clinical practice. However, as rumors of its incredible potential spread, there has been a concerning rise in online enthusiasts offering behind-the-scenes cures involving FMT. It goes without saying that you should understand that the classic phrase "please do not try this at home" is especially relevant here. Ray's response to his FMT treatment was similar to what has been published in the literature. 3 days after the microbiota transplant, he got out of bed. Heather described it as a miracle. If I spent more time discussing feces than might be comfortable, it's because FMT serves as a starting point for understanding the importance of the gut microbiome for human health. The extraordinary benefits of FMT for some patients have opened the clinical world's eyes to the idea that our microbes can play a crucial role in the onset and treatment of diseases, even when their involvement contradicts medical science. The scale of the task is immense. The bacteria in the gut alone weigh about 1.5 kilograms and consist of roughly 100 trillion bacterial cells, that's 100 trillion, equivalent to the total number of cells that make up the human body. And they speak, in millions of different languages, to each other at the molecular level. Another significant challenge in studying the microbiome is its physical distribution. The microbiome is also unevenly distributed throughout our intestines. It's important to have a clear understanding of this. We are only beginning to map the entire microbial life in the vast ecosystem within our bodies and to understand how it connects us to the world around us. In this backward world, stool has become a therapy used to replenish our fragile internal ecosystems that are lost as quickly as they are discovered. Even considering the impressive achievements in biology, metagenomics, and bioinformatics, computational biology, we may not be able to count and name all the beneficial microorganisms that live within us before they go extinct, mutate, or evolve into something entirely different. We are decoding the molecular language of the human microbiome, which is one of the greatest challenges of modern medicine, and fecal transplantation is an important and fascinating tool used to uncover these secrets. The human microbiome represents the most important new therapeutic target we have for addressing the greatest threats to human life in the 21st century and for preventing future pathogen pandemics. This is not only important for Ray, it is critical for all of us. Without a stable and diverse microbiome, we may very well go insane. There is data from some studies indicating an altered microbiome in borderline conditions in psychiatry. The simple message behind all this is, microbes are not enemies.